In recent years, modern internet services such as video on demand, online gaming, and video conferencing have become prevalent, leading to substantial increase in traffic and posing strict service requirements to networks. At the same time, operators are reporting a growing number of traffic surges, generated, for example, by software or game releases, and link failures caused, for example, by cable cuts. Ideally, operators need to have the best available tools to perform traffic engineering, but unfortunately, on the internet, this is not the case today. For example, suppose a scenario where a network A is connected to 2 transit providers and 1 IXP. Then, a traffic surge caused by a software release by D congests both transit links of A, resulting in performance degradation for all the traffic being sent through these links. This is represented in the picture by the traffic going to C. In this case, even being physically connected to an IXP where some members can reach C, A cannot send traffic towards C using the IXP link because it does not have an interconnection agreement with these networks, namely ISPs 3 and 4. One reason for that is because these networks can have selective or restrictive peering policies. As it may take days or weeks to establish an interconnection agreement, A is not able to mitigate the impacts of the traffic surge. To solve this problem, we propose Dynam-IX. Dynam-IX is a dynamic interconnection exchange composed of a high-level interconnection intent abstraction and a trustworthy environment built on top of a permissioned blockchain. The intent abstraction allows operators to easily express their interconnection intents and establish dynamic interconnection agreements in short timeframes. The blockchain allows operators to do so without relying on any centralized entity to keep the confidentiality of agreements and business policies and to build trust among the ASs. Now, let's go back to our example and see how Dynam-IX works. In our example, A wants to find a new path to C. Thus, A will query the blockchain to find potential providers that can satisfy this demand. Next, A will query the providers for offers. The providers will verify their interconnection intents, which are specified using the high-level intent abstraction, and the ones interested in establishing an interconnection agreement with A will reply with an interconnection proposal. Then, A will select one of the offers and contact the provider to confirm its interest in establishing the interconnection agreement. Finally, both networks will update their routing policies to reflect the new agreement, and the traffic will start to flow. This is Dynam-IX, transforming interconnection intents into real agreements.